What is the biggest mistake the medical industry is making when treating cancer?
Well, that's kind of a broad question. They're not making one mistake. They're making many mistakes. The consequences of that are over 1,700 people a day in the United States dying from cancer, over 618,000 people a year. By the time you and I are finished with this discussion, 70 people in the United States will be dead. And also, when we magnify that around the world, you're talking an enormous amount of people that are leaving the planet as the result of a misunderstanding about the origin of what this disease actually is. Cancer is a disorder of energy metabolism, mitochondrial dysfunction, where the field throughout the world seems to think that cancer is a genetic disease. So they're spending enormous amounts of money and approaches either hunting for genes or trying to target genes for a disease that's ultimately not genetic.
Yeah, okay, so I want to get into how to manage it and everything like that. But I heard you say that perhaps the treatment for cancer will go down as the greatest tragedy in modern history of medicine.
Well, I think so, because they're treating it as for something other than what it is. I mean, you're using toxic poisons and radiation, surgical mutilations. These approaches are done in an incorrect way. If the tumor cell cannot survive with simple metabolites like the sugar glucose and the amino acid glutamine, and the tumor cells are incapable of transitioning away from those two fuels to fatty acids and ketone bodies, the logical strategy would be to deprive those cells, that tumor in a person, of those two fuels, while transitioning their body over to a state of nutritional ketosis. This will demolish these tumors, stop them. We don't ever use the term cure. We use the term management because we don't know if anyone is cured. All we know is they live longer with a higher quality of life. And that doesn't mean we can't use radiation or toxic poisons. They would be used in very low doses at strategic times when the tumor cells are massively compromised energetically, being just barely hanging on for survival. A small dose of a toxic poison could be considered, just like a small dose of radiation and a surgical procedure to remove whatever residual mass might be there.
Yeah.
So you'd have to redesign how we use some of the strategies. Right now, people are all excited about immunotherapies. Immunotherapies are, again, based on the genetic basis of tumors. You're trying to target tumor cells, but the epitopes or the targets are massive in great number, and they're always concerned that the tumor's acidification prevents the immunotherapy from working. Where does the acidification come from? It comes from the sugar glucose and the amino acid glutamine. If you get rid of them, the tumors become extremely vulnerable to a large number of what we're already doing, especially if the patient is in nutritional ketosis. I mean, we have so many unique ways of killing cancer cells without causing any toxicity to the patient. Wow. Why are we doing what we're doing? That's why I said this is medieval.
Yeah.
And we publish these papers in top journals. We have case reports showing the therapeutic efficacy, but it's pretty much ignored.
And why do you think is that? Do you think that there's something intentional? Or?
No, it's not intentional.
It's ignorance.
A lack of knowledge, I think.
Yeah.
Well, it's also a desire to maintain the status quo.
Oh, yeah.
I think anytime you change a paradigm, I don't care what it is, there's a lot of a disconcerting feeling about this. I've been doing this the same way for decades, and I don't want to change. But, in the case of glioblastoma and some of the more deadly cancers, we haven't made any progress in 100 years. And yet they continue to do the same thing over and over again. Yeah. And most of the poor folks are dead within 5 years or less, even within a few months. And they won't change. Despite the fact I've published beautiful papers showing how the standards of care, the way they're done today, are killing a majority of these people. Many people are dying from the treatments rather than from the cancer. So this is nuts. And yet we have a clear path to providing a logical solution to this problem based on the science. The science is telling us to go this way, but the field resists for a variety of different reasons.
The most alarming thing I think about the things that you are saying is the fact that other than the keto diet and all the things that we can do with metabolism treatment, the thing that the medical industry is just not going in the right direction at all, even reversing the right direction.
Yeah, well, I think so. I mean, all you have to do is see the advertisements. No one's talking about nutritional ketosis as the starter for making or having standards of care work. And that tells you that the system is very reluctant to change. Yeah. But I look at it as a humanitarian thing. These people are dying. I mean, these people are dying horrific, painful deaths, either from the tumor or from the treatments that they're given.
And you think that the way to treat it is by making the public more knowledgeable of the things?
Well, I think the public should know that there is an approach. And we never say we have a cure for cancer, ever. We just say we have a strategy for managing cancer, improving overall survival and quality of life. We have some individuals that have been using metabolic therapy with terminal cancers for over 10 years, but the tumor is not gone. So they're not terminal either. So, but they've lived far, far longer with a higher quality of life than would have ever been imagined. Whether a person gets a cure or not, we don't know. But what we have is far better than what the strategies that we have. And as I said before, we don't throw out standards of care. We don't throw out immunotherapy or toxic radiation or poisonous chemicals, which they are. We just learn how to use them more strategically. Rather than as a beginning treatment, we use them as an end. In other words, when you have just a few residual tumor cells hanging on, a small dose of a toxic poison could possibly eliminate them, but it would be much lower dosage, and your body is already protected against the poison by being in nutritional ketosis. So we have a way to transition the whole body over, so the normal cells in the body get stronger and stronger and healthier. The tumor cells get weaker and weaker and closer to death, and thereby we can push them over the edge quite effectively by combining a variety of different tools. We have all the tools in the tool chest for effectively managing cancer today. We just have to learn how to use them in the appropriate way.
So first of all, can you give us a bit more statistics about the things that you see day to day in these treatments?
Well, we have papers that are published from people that have terminal cancer, and I mean terminal. I mean, we have the breast cancer woman from Ohio. We've published her paper in Curis. She was given 1 month to live. She had breast cancer. It metastasized to her bone, her brain, liver, and lung. She went to our colleague's clinic in Istanbul, Turkey, and received metabolic supported chemo, which is putting her into nutritional ketosis and using low doses of chemo. And she's out now over 5 years, and she's very healthy. And she was supposed to have only 1 month to live. People say, well, these are anecdotal.
Yes.
They're published. I mean, what do you want? I put all the data in there, anecdote or not. I mean, glioblastoma, 10-year survival. Does it happen to everybody? No. But the fact is that you can get some of these people to do far better using metabolic approaches than you can using the standard of care, should open the floodgates for people to come in. The first thing they should say, I want metabolic therapy for managing my cancer. And the physicians will say, what's that? And they say, well, I have to lower my glucose and elevate my ketones. Oh, no, you can eat whatever you want. Take as much carb. But this guy, these kinds of folks just don't know. They lack knowledge. They're not trained. But it's not their fault. Yeah. They have just been trained by a system that itself doesn't understand the nature of the problem. So it's a combination of failures up and down the whole spectrum. The patient doesn't know about the nature of the disease. The very person treating the patient has no clue about the nature of the disease. And the industry is not interested in knowing about the nature of the disease.
Seems like a vicious cycle.
It's really hard.
And it probably feels like an uphill battle for you.
All these major paradigm changes have always been uphill battles.
Oh, yeah.
The field just doesn't turn around a multi-billion-dollar industry and say, oh, we've been making a mistake.
Yeah, how much of it do you think is the financial side is playing?
Probably the financial side is the number one reason why we can't manage cancer effectively. Unless one can find out how to rechannel revenues. And not to say we're going to get rid of any. We can simply charge more for giving much less. I mean, if you want to do the most important thing is doing it the right way. Okay, and I don't think people would mind paying money if they knew that the outcome would be good. Right now, someone is diagnosed with cancer, and they have a terrible anxiety. They think the Grim Reaper is looking over their shoulder, waiting for them, and that doesn't have to happen. We're trying to put the Grim Reaper out of business, but they need to know what to do. Our metabolic therapy requires a tremendous input on the part of the patient. The patient must understand what they have, and the patient must understand what they need to do to bring their blood sugar down and their ketones up. And that's why we developed the glucose ketone index calculator, which we published here at Boston College, which will be the tool by which we can manage cancer and all major chronic diseases as well.
Yeah.
Because we're putting people back into the period when we existed on the planet in the Paleolithic period, 400,000 or 500,000 years ago. All of our ancestors were in nutritional ketosis. There were no donut shops and delicatessens on the corners in the Paleolithic period. So they killed animals and ate them. Whatever they could find, they would eat. And they were always a low-carb diet, basically. So a lot of exercise, low-carb. These people, we know because those who live according to traditional ways rarely, if ever, have cancer. Scientists like humanitarians who have gone around the planet looking at people, rarely do they have cancer. What killed our ancestors was injuries and infections, not chronic disease, obesity, cardiovascular disease, cancer. Those things that rarely, if ever, existed.
Yeah, people might say for the argument against it is that they lived much shorter.
Yeah, but they were dying. They didn't have an osteopathic surgeon to fix their broken bone, nor did they have antibiotics to reduce the infection that they had. So if they had orthopedic surgeons and antibiotics, they would live very long, because you would eliminate the critical thing. As long as but the problem is our science and technology has evolved so much faster than our biology. We are still Paleolithic man living in a very toxic environment, highly processed carbohydrate foods, anxiety, poor sleep, all these things putting us at risk for cancer, cardiovascular disease, diabetes, obesity, all these kinds of things are the result of the new environment we're living in.
Can you please elaborate? A couple of things. So first of all, I do think that the way to maybe change the paradigm, believe it or not, maybe I'm optimistic, but I think it's through public knowledge, and this is why I do this.
Yeah, well, I think you're right. I mean, but again, you have people that will never care, but that's okay. We always have those kind.
Yeah, of course.
But I think the majority, if they knew what to do and how to do it, I think they would take their life in their own hands.
Yeah,
and that's why we developed this glucose ketone index, because we have built a chart for this that will tell a person, and with their continuous glucose ketone monitors, you can then look at your phone and be able to know at any given time of the day, we're working on this, what zone you're in with respect to risk. Are you in the zone of risk for cardiovascular disease, cancer, and dementia? Or are you in the management zone? Or are you in the prevention zone? Because we know that cancer involves mitochondrial dysfunction coupled to a substrate level phosphorylation, which is a fermentation. And as long as you can keep your mitochondria healthy, it's very hard to get cancer or any of these chronic diseases. So it's a mitochondrial centric issue here. And I don't know if enough people in the clinics know that the mitochondria is responsible for your ill health. Mitochondrial dysfunction. What gives you mitochondrial dysfunction? Lack of exercise, eating highly processed carbohydrates, being stressed out all the time, poor sleep, having no friends. All these kinds of things impact negatively on our physiology, causing the mitochondria to become damaged. And either those cells will drop out and die if they can't transition to an ancient fermentation mechanism, where they start to use glucose and glutamine fermentation to drive dysregulated cell growth. And then you get cancer. You could have diabetes, you can have all the chronic disease and dementia. We put them all into the same thing, all as the result of various types of mitochondrial dysfunction. So this whole thing we created this problem for ourselves. This is not something, it wasn't our genes that made we evolved to be very, very hardy and tough people. And when you think of the hundreds of thousands of years we were eking out an existence, and then all of a sudden, within a few hundred years, we're thrown into an environment where abundance is overwhelming in the things that are actually unhealthy. And then we wonder why we have all these diseases. Give me a break. You need to understand evolutionary biology. And when you understand evolutionary biology, everything makes complete sense. We have an obesity epidemic, right? That obesity is evolution in action. We are a starved species. We can go long periods of time without food because who knew when the next meal would come? Do you know how hard it is to kill a big buffalo or an elephant to get food? I mean, it's not easy. You're not going to go out and throw something in a microwave. It takes a lot of energy to kill a buffalo or an elephant.
Yeah, and it's
right?
a buffalo right now, and tomorrow it's rotting buffalo.
Yes, you do all that, and that's a lot of energy. You're using a lot of time to spend to do this, and the food is all natural. It's not it's organic, I guess you could say, but clearly it's would keep us healthy. Yeah. Then all of a sudden we developed all of these food science and technology, allowing food to be on a shelf for months. I mean, I have a Twinkie in my office. You know what a Twinkie is?
Of course, yeah.
Okay. It's 12 years old, and it looks brand new. And I had a mouse break in a couple of years ago through the wrapper, and he ate the Twinkie. He didn't seem to care that it was 12 years old. It was very tasty. So I mean, we're making foods that look normal and look healthy, and it's completely chemical. It's all chemicals. Then we wonder why we have dementia and obesity. So obesity, as I said, is evolution in action. We have genes in our body that are supremely designed to store energy because we were always going to be starving. So then you take those same powerful genes, and now you have this abundance of carbohydrates, and you get fat. I mean, this is evolution in action. We were not supposed to be. We didn't evolve to be fat. We evolved to be lean.
Yeah, it's a feature, not a bug.
Yeah. Yes. So whenever you see obese people, it's evolution in action. You don't know about biological evolution? Obesity is right there in your face. That tells you. Those are the people that are obese today were the survivors of great food restriction in the past, because the people that didn't have the genes to store energy died. Yeah. So the people that had the storing energy lived, and their offspring, we see them today. Yeah. And when people say obesity is a disease, it's not a disease. This is foolish. These are people who lack knowledge. They have no clue about evolutionary biology. So we're making it look like, they have some sort of an affliction. You know, it's their biology that's evolved over millions of years to say you are a survivor today because your ancestors could store energy. Whoa, if they couldn't, you wouldn't be fat today.
That's so fascinating. Yes. So the thing I think might help some of the people listening. You said that the Paleolithic world, the people were all on the ketogenic diet.
Well, I don't want to call it a ketogenic diet because people ate a lot of meat.
Yeah,
which is low in carbohydrate.
Oh.
So when
I just wanted to ask what it is.
It's a low carbohydrate diet. So you would be eating a tuber if you could find one, but they were all natural plants. You know, some berries, nuts, and animal products. As a matter of fact, there was a paper I think earlier this year out of Israel actually with cavemen. They were looking at bones and things what they were eating, and it was very interesting. This was Paleolithic time, even before Neolithic is when we started to cultivate grains about 10 or 12,000 years ago. So you talk 100,000 years ago. What were these guys eating? They were killing and eating large animals. But what was very fascinating about the story, the archaeological evidence, was they were killing and eating the strongest members of the herd. Apparently, our ancestors knew that the greatest amount of energy would come from eating the strongest animal in the herd, leading to lack of protection, causing the extinction by predators. So if human beings are eating the strongest members of the herd or the group, that leaves the very young and the very old vulnerable to predatory activity, leading to the extinction. So man indirectly led to the extinction of several types of large animals because we ate the tough ones. So we obviously knew where the greatest amount of energy was coming from the marrow and from the meat of these strong animals, which would give us strength. But we put the rest of the species vulnerable to their natural predators, leading to extinction. So, we were a smart group of people, for sure. We knew where to get the best food and how to get it.
It does seem reasonable, yeah.
Yeah, of course.
But how does the ketogenic diet, what it is, what it's doing to the metabolism?
when you eat animal foods, if you're eating low carbohydrate, we don't like to use the word ketogenic diet.
Oh, so how do I...
Because you know why? In the medical profession, diet is ambiguous. People say, I'm on what diet? Oh, I'm going to eat this diet. What diet? Oh, we don't care. All you know is when you measure your blood sugar, your ratio of glucose to ketones, we look at it as nutritional ketosis. And we've defined the zones of therapeutic and nutritional ketosis. Some people could get into that diet eating fish. Some people can do eating meat, Mediterranean, as long as it's calorie restricted. It's a little harder on vegan diets because there's so little protein in there. You're like a farm animal chewing grain all day long. I know some vegetables, but it can happen. It's just a little bit more challenging. But I think carnivore diets, calorie restricted, Mediterranean, pescatarian. So it's not the diet; it's the zone you're in. So the GKI, which we have a major paper under review right now, will allow an individual to know what they can or cannot eat. So it can be religious, cultural, age-wise, sex-wise. You can eat you will always, can I eat that or that? Eat it and see what happens. If your GKI goes up, don't eat that. If it goes down and puts you in the zone, then that looks like it's pretty good. As long as it's balanced for macro and micronutrients and generally restricted in calories, almost everybody can get into a state of nutritional ketosis.
And what's the benefits? And perhaps you can make it the difference between treating with keto or with low carb and everything for the cancer and dementia and everything, and for the common man or woman who wants to just benefit their life.
Well, I think now they have a tool. Now we have for the first time an actual quantitative measure. Because in the past, I'm doing keto. What's your GKI? I don't know. Well, how will you know you're doing keto? You don't know. So you measure, I guess I wasn't. So once they have the tool, they will know exactly where they are, what zone they are. So you can prevent, if you keep your mitochondria healthy if you're in a low GKI, glucose ketone index ratio, your mitochondria are burning ketones. Ketones are a super fuel. We evolved to burn ketones. We keep the reactive oxygen species down. Every breath of air we take, we get more energy per breath of air if we're burning ketones than if we're burning carbohydrates. So clearly, our bodies tell us if we're healthy or not healthy. Our mitochondria tell us whether we're healthy and not healthy. And I think we've been overlooking the signs of our biology telling us what is good or not. We keep throwing pills and drugs and all kinds of stuff at these. This is nuts. I mean, you get the patient into a low GKI, you can still take those drugs or things, but you take very little of them. You don't have to take them as often, and you take them very little on this. So humans always want the quick fix. They always want something that you don't really have to spend a lot of time knowing about or doing. But that's their problem. As long as they have knowledge, they can look at the chart, see where they are any given day, and then they can make a conscious decision as to what zone they want to be in. You want to be in the high-risk cancer zone, dementia zone? Hey, that's your choice. But at least you know you're in that zone. And you know how to get out of that zone and get into another zone by simply measuring your blood sugar and ketones in real time. And that's coming. These tools are coming.
It sounds amazing. But I want to get into the way that people can measure themselves these days, and we'll get it in a second. But I want to go back to cancer and the way that the things that you suggest are treating it. But if you can please elaborate first on how much of a problem is cancer globally currently.
Well, I think it's a major problem. It doesn't seem to be going away. It only seems to be getting worse, which should never happen now that we know what to do and how to prevent it and how to manage it. But again, it's not consistent with the worldview of what it is. But I think in China, it already surpassed heart disease as the number one killer of Chinese
surpasses
people.
the word you can use.
Yeah, I was there a couple of years ago, and I heard someone tell me from one of the Chinese statistics, they were 8,100 people a day were dying from cancer in China because they have a huge population. But you know, it's all connected to chronic diseases. Cancer is being one of them, one of the major ones. And I think it's different than diabetes or cardiovascular disease. You know, you have cardiovascular disease, you take some pill or something like this, or diabetes. But when you have cancer, you feel that you're going to suffer immensely, and there's no cure, there's no management, and you're eventually going to die. And if you happen to survive the poison treatments and the surgical mutilation and the radiation, if you happen to be so fortunate to survive all that, your body has been brutalized by these toxic situations where a tumor could reappear, either the same tumor or a completely different tumor some other place in your body, and come back at you in some other completely different way. We know from being exposed to poisonous chemicals and radiation and all this kind of stuff, people then suffer with survivor anxiety. They have hormonal imbalances, bone density issues, neuropsychiatric problems, digestive problems. All of these are the results of being poisoned and irradiated. So, I mean, I don't know anybody who wants radiation and poison to prevent themselves from getting cancer, right? You know anybody who does that? I mean, you might get a vaccine to prevent you from getting a virus or something, but you don't, you know, today's my day, I have to go down to Dana-Farber or MD Anderson to get irradiated to prevent me from getting cancer or take this toxic drink. You know, this is nuts. Yeah. So, but when you have cancer, they give you all that kind of stuff. It's like crazy. So, but no, I think that, yes, cancer is a major disease. I mean, the pharmaceutical companies are gearing up for a massive number of new cases by 2050. What's going on? We know how to drop those deaths. We know how to prevent it. We know how to keep people alive without doing that. And as I said, when you take people and you give them all these poisons, chemicals, and all this kind of stuff, you increase entropy, the second law of thermodynamics, which is disorder. Your mitochondria get brutalized by being irradiated and poisoned. I mean, you're damaging the very organelle in the cells that you need to be healthy, right? When you're in nutritional ketosis, the mitochondria are getting super, super healthy. And the tumor cells now become marginalized because the fuels that they're needed, like glucose and glutamine, are being targeted. Yeah. And that's why we have to know how to do this because we developed the press pulse therapeutic strategy where you can press glucose down real strong because you don't need it. We can switch to fatty acids and ketones. Tumors can't. So once they are put into this marginal zone, we come in strategically with glutamine targeting drugs. We're working on dosage timing and scheduling. So because the glutamine is so important for our immune system and our gut and just normal function in our body, we can't be too aggressive in targeting glutamine, the amino acid that's fermented by the tumor cells. So, but we can hold the glucose, and then we can come in and gradually degrade with the glutamine targeting drugs while the mitochondria and the rest of the body are getting super healthy. So all your normal cells are getting healthier and healthier and healthier, and the tumors are getting weaker and weaker and weaker. And eventually you end up in a zone where the tumor has been reduced to an indolent growth or an indolent state or gone completely. We don't know. But it's certainly, and you feel much better. We've seen people who come in with hypertension, high blood pressure, prostate cancer, and diabetes, and we put them on metabolic therapy, and everything starts to go away. The hypertension, the high blood pressure, the diabetes, along with the cancer, because they're all the result of damage to mitochondrial dysfunction in one way or another. Wow. So we want to restore the power of our mitochondria, because that ultimately determines how long you're going to live on the planet. It's the mitochondria. It's the energy system in our body. All of our cells have these mitochondria, except red blood cells, and they're turned over. But as long as we keep lung healthy, brain healthy, gut healthy, what means healthy? It means your mitochondria and those cells are healthy. How do you get them healthy? You have them burn ketones. How do you burn the ketones? Get into nutritional ketosis. But then you say, what do I have to do? Don't eat a lot of highly processed carbohydrates. Well, I don't know if I can do that.
Yeah, this is the hard part.
Then it becomes your choice.
Yeah.
But at least you know what to do and how to do it. Yeah. It's no longer a mystery. The mystery is gone. We know what to do to keep ourselves healthy.
But as you say, this is not the way it's being treated right now. And I do see why you would say this is a great tragedy.
Oh, yeah. Well, I think it's a tragedy of lack of knowledge. I think it's because sometimes the cancer patients are told, eat whatever you want. I've had people tell me the person weighs 300 pounds and they take a chemo and they're afraid he's going to lose too much weight on chemo. A guy weighs 300 pounds for Christ. I mean, what are you doing? You're worried about this guy because you're going to give him chemo, he might lose some weight. When you do metabolic therapy, you do lose weight. But the issue is therapeutic weight loss. You can lose weight if you're poisoned, of course. You're vomiting, you have diarrhea. I mean, this is terrible. You're losing weight. Well,
This is what happens during chemo?
Yes. Oh, yeah. Why is he throwing up? Everybody's talking. Why does he have diarrhea all day? Why has he got headaches? Why can't he get out of bed? I mean, you're poisoning the poor guy. I mean, he's not going to look like he's...
Can you please elaborate more on how the chemo is treating the patients and why does it...
Well, you see what they have, doxorubicin. They call it red devil. Makes you pee red, your eyeballs red, everything is red. It's poisoning your whole body, right? The cancer cells are dying, of course, too, but your normal cells are getting damaged. Whoa. Your mitochondria and the normal cells are being damaged as the result of that. Why are you doing that? People go bald, right? You ever see these poor cancer patients? They're bald. Why are they bald? You got cancer cells growing in the hair follicles? No. So why did you go bald? It's just an adverse effect. Well, listen, when you do metabolic therapy, your hair does not fall out. It actually starts to look even better than it was before. Yeah. So we've seen so much remarkable turnaround. And then the people, well, there's no clinical trials. There's no clinical trials. I can't believe it. That's just an excuse. The science tells us what we need to know and how to do it. Why didn't you look at the science? Why do you not want to do a clinical trial on this? We don't know. We don't know what to do. Well, we know what to do. We'd be very happy to show you. And then they always come up with some other excuse. Yeah. We can't do that because you're threatening their meal ticket on a lot of this. So you got to be careful. But we know what to do. We know how to do it. We have been publishing these papers. People will have to come and read. They're open access. You don't have to go to a library. You get it right off the web.
Yeah, but this is very proactive on the patient side or the general public. Yeah.
Well, I feel bad for so many patients. They run down to their top whether it's in Israel or Boston or New York City or California, they run to their top medical schools. Now, don't get me wrong, we have made major advances in medicine for heart health. Our orthopedic people have remarkable, hip replacements, knee replacements, all kinds of unbelievable advances in almost many fields except cancer. We're still in the Stone Age with respect to cancer.
Yeah.
So you don't do this if you understand the nature of the disease. And I'm not speaking as if I'm the one who started all this. Otto Warburg, the great German scientist, knew what cancer was, a metabolic disease. But we found out where he made mistakes and where he didn't have certain information that we now have. So I went back and I was able to clearly see what Dr. Warburg had done, and I found out where he made big mistakes and where the field continues to make these mistakes. And we've published papers showing how these mistakes have been identified. Now you can deal with them. And Warburg never developed a therapy, a successful therapy based on what he had discovered. We have done that now. With the press pulse metabolic therapy, we have now developed real logical ways to manage cancer based on our understanding of the science.
Can you just elaborate? What did he won the Nobel Prize, right, for something he discovered?
He won the Nobel Prize for his discovery of the respiratory enzyme, which is basically cytochrome C. And he was nominated many other times. He's also an interesting figure for history's sake because he was half Jewish. And Hitler spared him because Hitler felt that if anybody was going to cure cancer, it would be Otto Warburg. Oh. So why should? And there was a lot of animosity after the Second World War because of that. But believe me, he was no fan of the Third Reich or Hitler. So he just wanted to continue to do his research. And he was nominated, but Hitler didn't let Jews, or any German, I should say, receive Nobel Prizes during the Second World War. But he was nominated so many times for his work, but he only received one. And then, of course, after the war, when Watson and Crick found the structure, or at least defined the structure of DNA, the field ran off like lemmings over the cliff. following the molecular biology, finding abnormalities in the structure of DNA in tumors, thereby saying, "Oh yes, look at all the mutations in tumor cells." And we've been chasing that tail for the last 70 years, and it has
the genetic tail.
Yeah, the genetic tail, and we have more dead cancer patients today than we've ever had. So obviously, it's not working. Yeah. There's millions of mutation damage. And we find tumors now that some tumors have no mutations, so how are you going to target something that's not there? And now we're finding that these driver genes, they said, only some genes are really bad. They're called driver genes, KRAS, and all this kind of stuff. And we're finding these in normal cells of our body that have no dysregulated cell growth. So this is another problem. And then, of course, what I did is I went back and looked at all these nuclear mitochondrial transfer experiments, where completely showed that cancer cannot be a genetic disease. I mean, you have to be cognitively challenged when you actually look at the data to think that this is a genetic disease. And yet the field continues to push this stuff. And we get dead people. The result of that have brutalized people that are poisoned and treated terribly for the failure of the field to recognize what I'm saying. And if they don't believe me, read what part of the equation do you not understand? What part of the hard science do you not believe? Because I'd like to know. We've been trying to figure it out. We don't see any major challenge to the science. Wow. We just see it from conceptual belief systems. And you see when the patient goes to the oncologist, they'll say, eat whatever you want. Glucose has nothing to do with cancer. What are you, crazy? I mean, we have dozens and dozens of human experiments, animal experiments. The higher your blood sugar, the faster the tumor grows. Yeah. You got to keep the blood sugar down, and you got to target the amino acids and keep the ketones up so your normal cells start to get really healthy. So it's a combination of keeping your normal cells healthy and slowly degrading these inefficient tumor cells. And they say, well, tumors are very flexible. They're not flexible. All these gene mutations, they have prevent flexibility. They're locked into a fermentation metabolism. They can't choose. We interrogated the tumor cells asking, what can they live on? We just found out glucose and glutamine. They can't live on anything else. Yeah. So simple. And the cancer cells have been telling us this for decades. Our scientific studies show that all these tumors are throwing out lactic acid and succinic acid. These are the metabolic waste products of glucose and glutamine metabolism. And the cancer cells are throwing it out, telling us, this is what I'm using, this is what I'm using. And you choose not to target what I'm using, and it's just nuts. Yeah. So we have all the suffering.
Yeah, first of all, before I go into another matter, I hear in what you're saying right now. Can you please elaborate on the scale of the issue in America? Because as you said, in China, it's going like...
Well, it's all countries. I don't think it's just... I think the Chinese, I think in India now, all the countries are having the same problem. It's not just the United States.
As well in America?
Everywhere. It's everywhere. It's all over the world that cancer is increasing in all the countries. I mean, you look at we just published a paper just recently in the journal Oncology showing all the different arises in cancer, different kinds of cancers. We've made no major advance in lung cancer, pancreatic cancer, glioblastoma. We have made some small advances in some of these rare blood cancers. But for the most part, we have not made any major cancer. Once you hit a stage 4, they've been calling that for decades, you're considered terminal. What do you give me a break? Well, we see all these we're all terminal to some degree. Well, somebody says, oh, he's terminal. Well, he's been out 10 years. When do you think? Of course he's going to be terminal. He's going to die someday, but maybe not from cancer.
Yeah. But is it all the types of cancer? Or is it?
Yeah, we can't find a tumor that doesn't require glucose and glutamine. So they're all the same, very similar. Okay, their mitochondria are defective, therefore they must ferment. If their mitochondria are defective, they must ferment. What do they ferment? They ferment glucose and they ferment the amino acid glutamine. So we have shown that. They don't respire. We have now shown there are 3 sources of energy in our body. We have glycolysis, a fermentation mechanism in the cytoplasm of the cell. It's called cytosolic substrate level phosphorylation, which is the glycolytic pathway. In normal cells, it produces a very little amount of energy, but in the cancer cell, it can produce more. We have oxidative phosphorylation, which is you and I are breathing. Most of our energy is coming from the fact that we're bringing in oxygen. Our cells are making energy highly efficient with the waste product of water and CO2. I breathe oxygen, I exhale CO2 and water vapor. So this is the waste product of normal oxidative phosphorylation. But our big discovery, working with Dr. Christos Xenopoulos from Semmelweis University in Budapest, world leader on mitochondrial substrate level phosphorylation. This is something that's always existed, but it was never recognized in cancer, where the glutamine is fermented inside the mitochondria in the absence of oxygen. So the mitochondria can still produce energy without oxygen through a fermentation mechanism. It's called mitochondrial substrate level phosphorylation. Warburg did not know about this. As a matter of fact, most people in the cancer field have no clue about this. So that's why they keep doing stupid things. They need to understand the scientific literature. Once you understand the scientific literature, the solution is right there in your face.
But I thought, perhaps I'm mistaken, but lung cancer is the most deaths are caused by lung cancer. Am I correct?
Well, people smoke. And they live in lousy air, right? They're going to get lung cancer.
My grandfather died from lung cancer. So
but we know they're fermenting. Okay, so let me tell you something. If people have a heart attack, right, you stop breathing. And if you fall down, if you don't breathe within 5 minutes, you're going to be dead because your brain is going to die from the lack of oxygen. Okay, but your bloodstream immediately fills up with lactic acid and succinic acid. These are your bloodstream fills up with this because in order to remain alive, you have to have energy, ATP. Our bodies can make energy to ATP through absence of oxygen through what we call fermentation pathways. As I said, one is in the cytoplasm and the other one is in the mitochondria itself. The waste products of glutamine, amino acid fermentation, is succinic acid. The waste product of glucose fermentation is lactic acid. Okay, so the bloodstream fills up with lactic acid and succinic acid in the absence of oxygen. Okay, as soon as you breathe, these two go down. So you're starting to respire again. Cancer cells, even in the presence of oxygen, still make the waste products of cytosolic and mitochondrial fermentation. That means we know what's going on. Their mitochondria are defective. They have insufficient ability to make energy through respiration. So they're constantly fermenting. So what are they fermenting? The glutamine and the glucose. Well, how do you kill cancer cells? You must take away the fermentable fuels. They can't respire ketone bodies or fatty acids. They collect them in the cytoplasm as big lipid droplets. This is not a complicated problem. People say, it's the biggest problem. The cells have been telling us for decades. It's just that nobody understood what they were telling us, or they got a foreign language or something.
Yeah, the public likes to be led, but perhaps the medical industry...
Well, the scientists need to be led. The scientists themselves, they've been collecting the data and not seeing it. They say, these cancer cells, we all know they throw out tremendous amount of lactic acid and succinic acid. And as I said, that causes acidification of the tumor microenvironment. It's like the tumor puts a protective shield around itself from all the acidity. Well, where's the acidity coming from? Glucose and glutamine. So you take away glucose and no more acidity. Now you can come in and kill these guys with minimal doses of drugs or radiation or any of this kind. And you can shrink it down. I mean, we have so many unbelievable ways to kill cancer cells without toxicity. We don't need to be doing the crazy stuff that we're doing.
This is incredible, and I really hope some people with power in this field might listen and do what.
Well, we'll see what happens.